Alright, so we're going to look at application 65 from section 3. And so to note up here, we're working with the idea that the profit is equal to the revenue minus the cost. Or another way of saying this is the money you make is what you take in minus what you spend. Okay. And so we're going to read through this. Profit. Donna decides to sell fabric cord covers on eBay for $20 a piece. The material for each cord costs $9, and it costs her $100 a month to advertise on eBay. Let X be the number of cord covers sold. Write a polynomial representing her monthly profit. So the costs stand out for me really clearly here. This says that's a cost and that's a cost. So since those are standing out clearly, I'll put them over here. It's for each cord costs $9. So for each, they're telling us to use X, plus there's $100 each month. Her revenue or income is just these sales from eBay, $20 a piece. So R equals 20X. Now this is within a month, but what's nice here is asking for the monthly profit and saying that these costs and what happens are all within a month. We don't have to do anything with the time. The parts of the equation that talk about, or the parts of the problem that talk about the time, handle each other. So we'll blend these together. We'll put them all into our profit. And we'll start with the revenue. We'll bring in $20 per thing minus. Now because I'm substituting in a variable that has a negative sign in front of it, use your parentheses here because this is important. The sign is important. Now I'm going to distribute this negative, because we can think of a -1 hanging out front, and that's going to go to each of the terms in this binomial. And so I get 20x minus 9x for my first distribution, and minus 100. Minus 100 here. Getting each of the distributions coming in. So, putting this all together, I can collect my like terms, which gives me 11x minus 100. And what's nice about doing a profit from this is we can look at this and say, well, she's not going to make any money until this bit's at least $100, where she sold 10 cords, right? She sells 9 cords and she loses $1, but she sells 10 and she makes her first $10 profit. And so this representation of writing things is really nice because it can focus on what needs to be done instead of itemizing the individual compartments. And this is why polynomial representations are really good in collecting like terms. Can simplify what we're seeing. They can take this real world problem and put it into where we focus on, well, how many do I need to sell to start making money? And then you focus on getting that amount of sales.